Okay, hello everybody. This is the Bonding Basics Ionic Bonds worksheet, and it's a little tutorial of how to do this sheet. What we're learning about today is ionic bonds, and if you remember from the stability and bonding notes, ionic bonds are chemical bonds, and specifically they're chemical bonds when one atom or element gives electrons, I'm going to abbreviate electrons, to another element. That is an ionic bond. It's a giving of an electron, and then the other atom is taking that electron on. Before we learn how these bonds work, we got to do a little bit of review so that we can kind of be real quick and fresh with the parts of each of the elements. I'm going to show you how to do the first two, and then I'm going to have you do all of these on your own. We'll start with sodium. If we remember, the symbol for sodium is Na. We're then going to figure out the number of protons on a sodium atom. We do that by looking over at the periodic table. You have a periodic table in your textbook. The number of protons in a sodium atom is, of course, 11. We then got to know the number of electrons in a neutral atom. We're going to start out in neutral atoms. If this atom is neutral, it has 11 protons. It will therefore have 11 electrons. The next thing we need to remember is the number of valence electrons. Valence electrons can be found a couple different ways. One of the ways you could do it is you could take the number of electrons and you could actually draw out each of the little rings and put your electrons and build it out. That's ridiculous though. I have a much faster way. Faster way is to look at the periodic table, figure out which group it's in, and then remember that the group numbers tell you how many valence electrons there are. Sodium is in the very first group, group number 1, which has 1 valence electron. Of course, every element is trying to get to 8 valence electrons. So we got to think now, what is the number of electrons that will be either gained or lost by sodium? So let's think, is it going to be easier to find 7 more electrons or just get rid of that 1? Well, we're just going to get rid of that 1, right? So we're going to say sodium will lose 1 electron. This last box is really critical. This last box is going to ask us, what's the charge of the atom after it gets that full shell? And that has a special name. That charge afterwards is called the oxidation number. We'll look at sodium, and we know that sodium loses 1 electron. It started with 11 electrons. After it loses 1, it will have 10 electrons. 10 electrons versus the original 11 protons. Who's winning? Do we have more protons or more electrons? Well, we have more protons, and we have more protons by a factor of 1. So we have a charge on that sodium atom is going to be a positive 1 charge. Okay, if you get it, go ahead and roll through the rest of these. I'm going to do one more example. Chlorine. Chlorine has 17 protons. So a neutral atom of chlorine will have a total number of 17 electrons. These electrons will arrange themselves into shells. And if we look on the periodic table for our shortcut, we see that the valence shell of chlorine will have a total of, let's look over there, 7 electrons in the valence shell. It's trying to get a full valence shell, so it's trying to get 8, right? So what's it going to do? Get rid of 7 or just find 1 more? It's going to just gain that 1 more. That seems way easier than getting rid of 7. Okay, finally, the charge of a chlorine atom after it's gained that 1 electron. Let's go back and do some small number math. It started with 17 electrons, it gained 1, so now it has 18 electrons. Still has those 17 protons. Who's winning? Electrons or protons? Electrons. How much are they winning by? Well, they're winning by 1, and the charge of an electron is negative, so this atom overall has a negative 1 charge. After it gets a full shell, that's called the oxidation number for chlorine. There's also a shortcut on the big periodic table in the classroom. The little pink post-it notes have the oxidation numbers above each group. Okay, that is our basics. I would like you to finish these out. After that, you're going to come back to the next video where I'm going to show you how to draw the ionic bonds between several common elements. Thank you very much.